Question 4. Here we cannot use the calculator. This means we have to show all the calculations in writing. In this question, the triangle ABC is a right angle triangle where the angle B is 90 degree and the length of side AB is 4 plus 2 root 2 and the length of side BC is 1 plus root 2. We have to find the value of tan C in the form of k root 2. At first, let's draw the triangle just to visualize and put the points and put the values. So let's draw the triangle first, then now put the points A, B, C. Now put the values 4 plus 2 root 2 and BC is 1 plus root 2. Now we have to find tan C. The tan C is actually opposite over adjacent, that is AB over BC, but AB is 4 plus 2 root 2 and the length of the BC is 1 plus root 2. Now let's multiply both of our numerator and denominator with 1 minus root 2 and 1 minus root 2. Okay. Now in the next line, in our denominator we get 1 minus root 2 whole square, 1 square minus root 2 whole square. In our numerator we get 4 plus 2 root 2 minus 4 root 2 minus 4. Positive 4 and negative 4 cancels each other out. So in the next line we get minus 2 root 2 over 1 minus 2. So in the next line we can write minus 2 root 2 over minus 1, which is equals to 2 times root 2. So let's write 2 root 2. So this is the value of tan C, 2 root 2. Now in the next question, we have to find the area of the triangle ABC in the form of P plus Q root 2, where P and Q are integers. Let's say the area of the triangle is A. So we can write A equals to half times AB times BC. So half times AB, but the length of the AB is 4 plus 2 root 2. So we can write half times 4 plus 2 root 2, 4 plus 2 root 2, then times BC, but our BC is 1 plus root 2. So we can write times 1 plus root 2, 1 plus root 2. Now if we take 2 common from the first pair, we get 2 plus root 2 inside the bracket, then followed by 1 plus root 2. Okay. Now 2 divided by 2, in the next line we can write 2 plus root 2 plus 2 root 2 plus 2, which can be written as 4 plus 3 root 2. So the area of the triangle is 4 plus 3 root 2. Now in the last part of the question, it says that there is a square whose side of length is AC. We have to find the area of the square in the form of S plus T root 2. So AC square, AC is the hypotenuse. So using the Pythagoras theorem, we can write AC square equals to 4 plus 2 root 2 whole square plus 1 plus root 2 whole square. So 1 plus root 2 whole square. So now let's expand these squares. From the first expansion we get 16 plus 16 root 2 plus 8. From the next expansion we get 1 plus plus 1 plus root 2 plus, sorry, 2 root 2 plus 2. So in the next line, after doing some addition, we can write 27 plus 18 root 2. So the area of the squares of side AC is 27 plus 18 root 2. So question 4 is done. Now let's go to question 5 in the next page and try to solve it.